All right, so let's continue on talking about this. So what we have to have is we have to have an extra wire. We have to have a wire that energizes that little miniature solenoid so that it energizes the pilot valve so that it can use the high pressure to move the refrigerant, right? You guys notice when you turn that thermostat to off, you hear a loud whoosh noise? Yeah. Well, and it doesn't do that in the other unit, right? No. The reason is because when we kill that solenoid valve, the spring in there moves it back to where it should be on the pilot valve. Then that moves over here the pressure from the high side to the other side, and it allows this to move back the other way, and it dumps the high pressure into the low pressure. What happens is most of the units, about 90% of the units, have it naturally, it's naturally in heat mode.
In Vegas, really?
So it's naturally in this. Well, they're not going to manufacture the units for the north one way and manufacture a different set of units for the south a different way. So it's naturally in heating mode. And we have to make it, or what we call activate, for cooling mode. The reason is without air conditioning, the majority of people are uncomfortable. Without heating, people die. Yep. People freeze to death. They die from being too cool. Now, when it gets hot, it's like, it's hot. My feelings. Some people, especially like some of usually it's the elderly people, they have much more of a time dealing with the heat. So they're the ones that are susceptible to heat. But the majority of people can handle the temperature. So excluding Vegas, because Vegas it gets so extremely hot that it could still be an issue. But yet heating is needed. Air conditioning is a luxury. People are surviving in hotter climates than us without air conditioning. Right? So it's naturally in heating mode. Most 90% of the units do it like this, and it's an activated for cooling. Cooling activated reversing valve. Naturally it's in heating. But when I send 24 volts to that solenoid coil, then it makes it go into what mode? Cooling. That's why we call it this is called a cooling activated reversing valve. It's a cooling activated reversing valve. It's a reversing valve that is activated in cooling mode. When it's not activated, what mode does it go in? Heating mode. So in the lab out there, I had to make it go into heating mode. How did I make it go into heating mode? Nope. Thermostat wouldn't do it. I unhooked the wire to the reversing valve. By unhooking that wire to the reversing valve, it went naturally into what mode? Heating mode. Heating mode. The thermostat was trying to call for cooling. It was too hot in the lab to get the heat to come on. So I set it for cooling. Everything ran. But what I did in cooling mode is I unplugged that reversing valve. By unplugging the reversing valve, what happened? Automatically goes to heating. Automatically it goes to heating. Isn't that cool? The majority of the units do this. The majority of them, which means most of them, use this. And what they use is the letter O. O stands for cooling activated reversing valve. Cooling activated reversing valve. So if it's a cooling activated reversing valve, what mode is it naturally in? Heating. So I have to activate it to go into cooling, but it's naturally in heating. It's a cooling activated reversing valve. So if I send 24 volts to activate that valve, it will go into what mode? Cooling mode. I'm saying this because people in the past have notoriously gotten hung up on, well, why do they use those words? I don't know. It's the words they picked. I need to make sure you guys understand them. Most of the time, they use the letter O, and that's for a cooling activated reversing valve. To activate it in the cooling mode, I have to actively send 24 volts to activate the electromagnetic coil that activates the little pilot valve, that activates the valve pressures to move over into the cooling mode, so it's activatedly in cooling. It's a cooling activated reversing valve, right? So the letter O. So on a regular unit, before we got to heat pumps, a regular unit, when I called for fan, what did thermostat do? No. It connects R to G. 24 volts goes to an energized electromagnetic coil, which then switches the high voltage switch wires that brings on the fan, right? When a regular air conditioner calls for cooling, what does it do? R to G and R to Y. So on a regular AC only, call for cooling, thermostat connects R to G and R to Y. On a heat pump, when it calls for cooling, what do you think the thermostat does?
R and Y? Connects R and W?
Well, it connects R to G because I still need the indoor fan, right? Don't we need the indoor fan running?
Yeah.
So it's still going to connect R to G. Do I need my compressor running?
Yes.
So it's still going to connect R to Y. What else do I need to do?
R to W.
I have to connect R to O. R to O. Because it's a cooling activated reversing valve. To make it go into cooling mode, I have to activate the reversing valve. That's where the letter O comes in place. The thermostat, when it calls for cooling on a heat pump, connects R to G. It will connect R to Y. And it will connect R to O to activate the reversing valve. On a regular unit, when I call for heat, what does it do? Connects R to W. On a heat pump, when it calls for heat, what does the thermostat do?
R to W, R O. So the G and Y.
It connects R to G because the fan's inside, right?
Yes.
It also connects because we need the compressor running because it's naturally in what mode?
Heat mode.
It's naturally in heat mode. By connecting R to G, does my indoor fan run?
Yes.
On a heat pump, if I connect R to Y, will my compressor contactor engage? Will my compressor run?
Yes.
If my compressor is running in a heat pump, does it naturally absorb heat from outside and reject heat inside?
Yes.
Will it not be heating? It will be heating because it's connecting R to G and R to Y. It's absorbing heat from outside the house and dumping that heat inside the house. So on a thermostat, this is a regular thermostat, and this is a heat pump T-stat. What happens if I put a regular thermostat on a heat pump? Now, what happens if I have a regular thermostat calling for cooling on a heat pump? Yes! It'll be in heating mode. Yes! It's exactly right. It's going to be in heating mode. Because it's connecting R to G and R to Y, the compressor's running. And on a heat pump, if you run the compressor, what's going to happen? You're going to be absorbing heat from outside, bringing heat inside. You're going to be heating the house. Do you want to heat the house in the summertime? Then don't do that. If I need cooling on a heat pump, I must also energize O. Now remember back to electrical when I told you guys what the letters stand for? And I made you say it was R, 24 volt power, not red. Because on the units, we went into that float switch, and the float switch was black, right? And then it came back out and into a red and whatever, some other colors. But it's not always red. Now also, I told you guys that Y stood for what? Compressor contactor. I did not let you use yellow because that color changes. And I also did not let you use the word cooling. You're like, well, why not? Doesn't it make cooling happen? And I said, for now it does, but later it's going to change. This is where it changes. Y, in this case, means compressor contactor, energized that have cooling. Over here, Y, compressor contactor, but I end up with heating. Y brings in the compressor. Y goes to compressor contactor. Either way, Y compressor contactor, Y compressor contactor. Does that make sense? Yeah. This is why. The whole reason I made you guys do it then is because I knew that heat pumps were coming, and I wanted you guys to be prepared when we got here. So now we're here. Y stands for compressor contactor. G stands for what? Indoor fan. If I run the indoor fan and my compressor on a heat pump that's a cooling activated, but I'm not activating the cooling, what mode am I going to be in? Heating mode. You see what I did in the lab now? By unplugging that one wire, I deactivated the reversing valve. What mode did it go to? Heating mode. Does that make sense? Isn't that cool? One wire. The other wire, the other reverse valve is common. It's going home with the other common to the transformer. Isn't that cool? So a heat pump will have more wires. Now in the old days, we had to buy a thermostat for regular AC and a separate thermostat for heat pumps. Did you guys know that? You should have. I just told you.
This guy.
Now we have an extra connector.
Now what is cool is, see that thermostat in the wall back there?
Yeah.
That is a digital thermostat that's also universal. With this thermostat, I can go into the programming. It's going to have a little book that comes with it. And that little book, we go into the programming of this, and by pressing key combinations, I can set this thermostat up to work with a heat pump or a regular AC or a gas furnace or a water-cooled condenser or any other thing that I need to set it up for, because one thermostat, and it digitally has all these components in it. It's another reason why I like those digital ones. You can have one thermostat, and it does everything you want it to do. If you want it to be programmable, you can make it programmable. If you want it to be non-programmable, because some people you don't want to have extra buttons, you can make it non-programmable. How awesome is that? It is amazing. It is amazing. Like zing, but amaze.
Alright, pro tip guys. The cooling activated reverse valve won't be orange. This may.
Might not be orange. It will be the O terminal at the thermostat. But many times, I don't have an orange wire to use. I made it using a green wire. I've wired many heat pumps with a green wire. No, it's not mean, it's necessity. Let's talk about why that would happen. So, here's a thermostat. Here is your air handler, or your inside unit. Your thermostat wires only to your inside unit. So at my inside unit, I'm going to have the letter R, I'm going to have C, 24-volt common, I'm going to have the letter G. That's about it. Oh, W. The thermostat's going to have R, G, W, and Y. So if it's digital, it will also have a C, only if it's digital. Do you guys know that?
No.
What letter does the thermostat have that the indoor unit does? Because is there a compressor contactor inside? No, it's outside, right?
Certainly hope not.
So here's the outside unit. We have our compressor contactor, right? One of these will be Y, one of these will be C. Doesn't really matter, it's alternating current. So let's wire this up. This gets complicated, right? I'm going to connect the R terminal from the thermostat to the R terminal at the air handler. What? I'm going to connect the G wire from the thermostat to the G wire of the air handler. I'm going to connect the W wire from the thermostat to the W wire of the air handler. I'm going to connect the C wire of the thermostat to the C wire of the air handler. The Y wire, I'm going to bring and it's going to have to end there because it has to be the same length as the other, so it's just going to stop right there. I'll get to the others in a minute. Now when I buy this, how many wires do I need? 1, 2, 3, 4, 5. I need 5 wires. It's going to be 18 gauge. Oh. So this is what we call 18.5. This is going to be the gauge. This is going to be the number of strands. We call it 18.5. There's 18 gauge wire. There's 5 strands of them. When I buy 18.5, I end up with the colors red, green, white, yellow, and blue. So what color do you think I will use for R? What color do you think I'll use for G?
Green.
What color do you think I'll use for W?
White.
What color do you think I'll use for yellow?
Yellow.
What color do you think I'll use for C?
Blue.
Blue, because there's only one left. Follow me? Now the outside unit. How many wires do I need to go into my outside unit for regular AC? Two. I need 2 wires. We'd call this 18-2. 18-2. Follow me? So for 18-2, it comes in 2 colors. You got one option. Have red and white. So that means one of these wires here is going to be red, and the other wire is going to be white. Follow me? So, this red wire, do I connect it to this red wire?
Yes.
Everybody agree? All right, let's do that. All right, now this white wire, do I connect it to this white wire?
No.
Well, come on, I thought you guys just said connect red together, right?
They spoke to why.
See, you guys are being wire racist. You're being air conditioner racists. You don't just connect the colors. Y stands for what? Compressor contactor. So that wire ends right here, and I'm put a wire nut on it. It was yellow here, now it's going to change over to red, right? And it's going to go to the outdoor unit, to the compressor contactor. And then coming back, I need to get back to 24-volt common. So I'm going to use a white wire, and I'm going to connect it to the 24-volt common air. So I'm going to have a white wire with the blue wire. If you strip the coating of that wire away inside, it's copper. It's all the same color inside. It all does the same job. It has to carry the electrons. I just need to make sure our 20-volt power, it sends everybody their specialty jobs. G is the doctor. He needs to go to the hospital. W is going to be the accountant. He needs to go to the accounting department. Y is going to be the guy building houses. He needs to go to the construction site. C, everybody's going to go home at the end of the day. Same apartment complex. So I don't want to send the doctor to the construction site. I don't want to send the construction guy to the hospital, surgery side. I need this W to get to this Y to get to the compressor contactor. It can change colors of wires as many times as we want. There's going to be a scenario to where I need to get the O signal to the outdoor unit. And I don't have an orange wire. But I will have a green wire. In any scenario, does the inside fan need to go outside?
No.
Do I ever need to get the G wire going outside?
No.
So I have an extra green wire not being used, right? So on the thermostat, if I add the letter O, there's not going to be an O here, but I have an O here for my reversing valve. I could connect O and actually be orange here, and then use green here to the reversing valve. My commons are still going to be tied together, and voila, I'm going home. Does that make sense? The color of the wire doesn't matter. I can go from orange to green to whatever color, as long as O from the thermostat eventually gets to my reversing valve.
Voila.
Voila! We are done. Isn't that great?
Yes.
How awesome is that? So what does O stand for?
Cooling activated reversing valve.
Cooling activated reversing valve. If I have an orange wire, could I use it? Oh, that's nice. Yeah, but we always have an orange wire. No.
Unless you're some kind of freak who has like all color wires.
Yeah, that's what me.
I know some people that they only carry what they call 18-8 wire. 18-gauge wire, 8 strands. Even if they need 2, even if they need 8. They carry 18-8. It's a lot more expensive. Do you think it's going to cost more to have wire manufactured with 18 strands or with 2 strands? 18 is going to cost more to manufacture. It's going to be a lot more expensive for that roll. How much more expensive? I don't know. Look it up. I know you guys are wanting to ask.
It's off in your head.
I was laughing because he said that all the
Like
wires are the
that,
same
or your
inside.
phone is a low battery.
Civil activist all of a sudden.
Oh, God.